All right, so let me explain what's going to happen over the next 4 days. So you've learned all that there is to know about forces. Inclined planes, net forces, the whole smash. F equals ma, coefficient of friction, the whole thing. So now it turns into an application process. So there's going to be two distinct parts to this. The first one is that I'm basically going to give you the problem and you have to find a solution to it. But this is how science is done. So the first lab that you're going to do, and I'll show you this in just a second, is going to involve a very, very, very strong magnet. Okay? And what you're going to do is you're going to see the effects of that magnet as it passes through two stainless steel plates. So this is what the purple sheet is laying out. I've got 5 setups. There's 24 of you. That means that I want 5 groups of roughly 4. Okay? There might be a group of 5 because it was like 24. So, but certainly I want 5 groups. Okay? You all are big people. I know some people are gone. You might have to compensate for that. But I want 5 groups out of the 24 of you. Okay? So, that's going to be the first thing. On the analysis, you are only going to hand in 1 analysis per group. Okay? So, not everybody's going to do it, but what I would suggest, because this all has to be typed, is that you somehow create a shared document that people can contribute to. What you're going to do, and this will make sense later on once you see it, is that you're going to do science. You are going to write a procedure that can be replicated by another group. Okay, so this is the benchmark of any scientific research. Can I take your procedure and replicate your results? Okay, that's your benchmark. Okay. Now, you need to lay it out, but you don't have to lay it out in minutia. Like if you say, hey, you need to tie a knot to hold the cart. You don't need to tell them how to tie the knot, okay? Oh, take the string, have it go around. No, you don't have to do that. But you do need to be a little bit more specific than just say, hey, cut a piece of string. Cool. How long is the string? I mean, you tell me to cut a piece of string. Do I cut it this long? Do I cut it a meter? I don't know. So there's a balancing act between, hey, let's get into the minutia versus, hey, you also have to tell them what to do. So there's going to be 2 distinct parts to this lab. Both of them have the idea of you're trying to determine the braking force of the magnet as it goes between the inclined planes. One of them, everybody's going to do the same in terms of the overall idea. How you do that, like which masses that you use, what distances do you use, that type of thing, that is up to you as individuals, groups, okay? That'll make sense when we get back to it. The second thing, how you define the second measure of braking force, that's open season, okay? You can do that however you want. If you want to do an inclined plane, if you want to just pull it to a certain velocity and then actually physically measure the force, I don't care, okay? But you need 2 independent ways to measure the value of the braking force. And again, when you write your procedure, the idea of the procedure is that can some other group take your results, read through them, replicate, include pictures. Y'all have, it's a digital world. Don't be afraid to incorporate pictures because a lot of times pictures are more easily understood than words are, okay? Because if you say, take the cart and put it on the ramp, and the front edge of the cart is at the 30 centimeter mark. Cool, but what you see is there's actually two different edges to the cart. You don't know which edge that you're talking about. But if you have a picture, that eliminates that ambiguity, okay? So, we're gonna start this today. We're gonna work on it all day today, probably all day on Monday. Then you're gonna have another set of more academic, theoretical problems, although one of them does involve a lab situation. That's basically gonna take Tuesday and Wednesday. We're reviewing on Thursday. Test is gonna be on Friday, okay? So your next really big test over forces is a week from today, okay? Got it? Good, bring it. All right, stop you on the camera, bring it with us to the back.